Hello out there, welcome again to this tutorial still on probability. This is the combination of events. We'll be looking at product law. This part 2 of this product law. Please check the description section of this video on our YouTube channel to get part 1 and other videos on probability. In this part 2, we'll look at dependent events. When two events E1 and E2 occur and the outcome of E1 affects the outcome of E2, then the two events are said to be dependent events. This is also applicable to more than two events in which their occurrences affect one another. The probability that both of them occur is the product of individual probability, that is, the product law is applied. So we take some examples. Example 1. A bag contains 5 green and 7 red balls. A ball is chosen at random and then the second one without replacing the first one. What is the probability that they are of the same color? B. Different colors. For your information, the choice of the first one is going to affect the choice of the second one since it is not replaced. So this is an example of dependent event because the effect of the second one is going to depend on the choice of the first one since it is without a replacement. So we look at what we are given. Green 5, there are 5 green balls there and 7 green and a total of 12 balls. And we look at the first example. Probability of the same color, it is either they are green or red. So green the first ball, green the second ball, or red the first ball and red the second ball. Pay attention please to see how this is going to be done. Now we look at the probability of picking the first one, green, and how it is being affected without replacement. So the probability of picking the first one, green, we have all the balls intact. So we pick the first one, that's going to be 5 over 12. So that one is gone. We are now left with 4 and the total number of 11 balls. So you can see now that the probability of picking the second one now is going to be affected since the first one is not replaced. So now the probability of picking is going to be product of probability of picking the second one. 4 green, now it has been reduced by 1 and the total number of balls, which is 11, will now give us over 11. All means addition. So we return the what? The green ball. Now the probability of picking the first one, if it is red to be red, will be 7 over 12. Then times, remember the first one has been selected, it is not going to be replaced before we pick the second one. So the probability of picking the second one here, since there are now 6 red balls, will be 6 over a total of 11. So we return the balls, they are now intact. If there is any other choice to be made again, we continue in that way. So now I can have 2 here, 2 times 5, 10, 2 here, 6 times 11, 66. Then plus 2 here, 3 times 7, 21 over 66. 2 here, 6 times 11. So that I now have it as 31 over 66. And that's the probability of selecting the same color without replacement. That is an example of dependent events. So we go to B part of the problem. For B, probability of selecting different colors. We know there are going to be 2 possibilities. Either the first one green and the second one red, or the first one red and the second one green. So we are going to treat it accordingly. Probability of the first one green times the probability of the second one red, then plus probability of the first one red times the probability of the second one green. So now the probability that the first one is green, since all the balls are intact, will be 5 over 12. The one is gone. So the probability that the second one is going to be red will be affected by the first choice, because we are now going to have 7 over 11. Since there are 7 red, so that's going to be 7 over 11. Then plus, then we return the first green, and now we go fresh. The probability that the first one is going to be red will still be 7 over 12 times, since one red is gone, the probability that the second one is going to be green and the green is still intact, we have it as 5 over 11. Then we now simplify. In the simplification, if you look at it, this is 5, 7, this is 5, 7. We can just simplify 1 and multiply by 2, since it is a number plus the same number, just like 3 plus 3. We can just make it 3 times 2. So we now say 35 over 132, then multiply by 2 over 1. And simplifying this is 2 goes here, 1, 2 goes here, 66. We have our final answer to be 35 over 66. That is the end of solution to problem 1, and we go to the next problem. So example 2, a basket contains 4 mangoes, 3 apples and 5 grapes. A boy ate 3 fruits from the basket. Find the probability that he ate A, 3 mangoes, B, 2 grapes and an apple, C, different fruits, D, the same type of fruits. For your information, the eating is done one after the other. He picks at random the first fruits, then the second, the third. The choice of the second one will be affected by the first one, and the choice of the third one will be affected by both the first and the second choices. So this is still an example of dependent events. So we look at what we are given: mangoes 4, apples 3, and grapes 5, and a total of 12 fruits. Now the probability of picking 3 mangoes is going to be the MMM, that is the first one mango, the second one mango, and the third one mango. And let's look at the way we are going to do this. The probability of picking the first one mango is going to be 4 over 12. One mango is gone and the total of the fruit has reduced by 1. So the probability of picking the second mango, that's going to be product of 3 over 11. Remember, one mango is gone, so we are left with 3 and a total of 11 fruits. Then times the probability of picking the third mango now. Remember, 2 mangoes are gone, we are left with 2 and the total fruit of what? 10. So this is it. Then we simplify. This is 12 goes with this 5. We have our answer as 1 over 55 as the probability of eating 3 mangoes. Then B part of the problem. The probability of eating 2 grapes and an apple will be 2G and 1 apple. There are going to be 3 possibilities: the first 2 grapes and an apple, or the first one grape, the second one apple, and the third one grape, or the first one apple, the second one grape, and the third one grape. So here we See that this is GGA, GA, GG, still the same thing. It is as good as since it is the same set of letters being rearranged. We can just simplify one and multiply by 3. Since this G, 2G's 1A, 2G's 1A, 2G's 1A. So it is acceptable. We just simplify one and multiply by, because it's still going to be the same set of numerators and the same set of denominators, just like in the just concluded example we did. So what we do here is we find the probability that the first one is grape, which is 5/12, times the second one now is grape. One grape is gone, so we'll be left with 4 and a total of 11 fruits. So we now have it as 4/11. And the third one is going to be apple. We still have the apple intact. So we have 3 apples, which is 3. And remember, 2 fruits are gone. That's going to be remaining 10. So we now have it as 3/10. And since we said here now, it is the numerators that will be changing here and there. So we just multiply by 3/1. And simplifying this, we are going to have our answer as 3/22. See this 12 going with this 12 again. This 5 here, 5 here, 2. So nothing. This 3 will be left. The 3, 4, 5 gone. We'll be left with 2. That's the 22 and the 3. We're done with B part of the problem. We go to C. For C, we have different fruits, probability of different fruits, which is the first one can be mango, the second one apple, and the third one grape, or the first one mango, the second one grape, and the third one apple. Now we go for the first one apple, the second one mango, and the third one grape, or the first one apple, the second one grape, and the third one mango. You have to be careful in your choice. Then we go for the first one grape, the second one mango, and the third one apple, and lastly the first one grape, the second one apple, and the third one mango. And we are going to still employ the method of simplifying one and multiply by 1, 2, 3, 4, 5, 6, since it is still the same letters rearranged. So it is going to give us the same value for all the 6. So we just multiply by 6 and we are there. So the probability of picking the first one, mango, will be 4/12. He has eaten that one. So there is now 11 fruits. So the probability of picking the second one, apple, we still have our apple intact. That's going to give us times 3/11. And the probability of picking now the third one, grape, will still be 5/10, because 2 fruits are gone. So 2 fruits are gone. What we are saying here is that if you pick the first one, mango, again, we still have 4/12. If you are picking the second one, grape, will be what? 5/11 and 3/10. So you discover that it is the numerator keeps interchanging for the whole 6. So what we do, we just multiply by 6/1. This is acceptable anyway, and from there we'll simplify, and that will give us 3/11. So you see this 12 is going with this 5, this is half, this will be 3, the 2 here will go with this 3/11. And that's the end of solution to example 2C. We go to 2D, the same type of fruits. The same type of fruits, either mango, 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 or apple, 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 or grape, grape, grape. So the probability of picking the first one, mango, is 4 over 12 times 3 over 11 times 2 over 10, plus the probability of picking the first one, apple, that's going to be 3 over 12 times 2 over 11 times 1 over 10. Remember, it is without replacement. You pick the first one, so apple is now remaining 2 out of 11, remaining 1 out of 10. The same thing here. Then plus probability of picking the first one, grape, 5 over 12 times the second one is now 4 over 11 times the third one, which is 3 over 10. And we simplify each of the brackets, and we want to maintain the same denominators, so that will give us 24 over 1320 plus 6 over 1320 plus 60 over 1320. Adding the numerators, we're going to have 90 over 1320. 0, we go with 0. This is going to give us 3 over 44, simplifying to the simplest form. And that's the end of solution to example 2. We go to example 3. Example 3, a bag X contains 4 purple and 5 blue marbles, and another bag contains 5 purple and 7 blue similar marbles. A marble is drawn at random from X and put into Y. A marble is then drawn from Y. Find the probability that the marble put into Y is A, the same color drawn from it, and B, different colors drawn from it. So we need to understand something here. There are 2 bags, X and Y. A marble is picked from the first bag and dropped into the second one. You know, the choice of picking another marble from the second one will be affected by the choice of the first one, since it is dropped into the second one. So this is still an example of dependent event. So we look at what we are given. For bag X, there are 4 purple and 5 blue and a total of 9 marbles. For box Y, there are 5 purple, 7 blue and a total of 12 marbles. So the probability of picking the same color is going to be purple from X, then purple from Y, or blue from X and blue from Y, since the same color will be purple, purple, blue, blue. Now the probability of picking purple from X will be 4 over 9 times, if purple is picked from X, it will be added to the purple here, so that the probability of picking purple from Y now will now be 6 over 13, because it is going to be 6 plus 7 at this point. That will give us 6 over 13, or that is plus probability of picking blue from X. Probability of picking blue from X is 5 over 9, and since blue is picked from X and dropped into Y, we will now have 8 blue marbles. So that probability of picking blue now from Y will be 8 over 13, because this is 8 plus 5 making 13. So I want to have maintain the same denominator in the simplification, because it is multiplication first. That will be 24 over 117, 9 times 13, plus 40 over 117, and that will give us 64 over 117. And that is the end of solution to problem 3A, and we go to B. For B, probability of picking different colors. That's going to be purple from X and blue from Y, or blue from X and purple from Y. So these are the possibilities. Either you pick purple from X and drop it into Y, then pick blue, or you pick blue from X and drop it into Y, then pick purple. The probability of picking purple from X for the first time and drop it in Y will be 4 over 9. And remember, the purple was picked and dropped into Y, thereby making the purple in Y to be 6, but the blue is still 7. Therefore, the probability of picking blue from Y now will be times 7 over 13, since this is 6 plus 7 giving us 13, and that's that one, plus the probability of picking blue from X and drop it in Y. If you pick blue, it's going to be 5 over 9. Then times the probability of picking purple from Y. Remember, blue is picked from X and dropped in Y, thereby making the number of blue to be 8, but the purple is still 5. So that will give us 5 over 13. So I want to maintain the same denominator. 4 times 7 is 28 over 117, plus 5 times 5 gives 25 over 117. So that 28 plus 25 will give 53 over 117, which gives the probability of picking different colors. So we are done with example 3. We go to example 4. A group consists of 4 men and 6 women. A committee of 3 is to be formed, in which the members are randomly selected. Find the probability that A, they are all men, B, one of them is a man, and C, at least 2 of them are women. 2 of them are women. So what are we given? We have 4 men and 6 women with a total of 10 members in the group and a committee of 3. So meaning probability of selecting 3 members. So we now have the restrictions, as they are all men, one of them is a man, and the rest. Now the probability that 3 men are in the committee, or all the committee members are men. Remember, this is the concept of dependent event. The first person will be selected, you come. A has been selected. Now, the probability of selecting the next person will be affected by the first choice, and the third will be affected by the first and second choices. So the probability of selecting the first man is 4 over 10. Then the probability of selecting the second man now will now be 3 over 9. And the probability of picking the third person will now be what? 2 over 8. So we simplify this to give us 1 over 30. This and this go with 8. This is 1 over 3. So 1 over 30. Then the B part of the problem, probability of selecting 1 man and 2 women. So it is going to be MWW or WMW or WWM. the probability that the first person is man and the second and third women, or first person is woman, the second is man and the third is woman, or the first woman, the second woman and the third man. We still look at bringing them, simplifying 1, then multiply by 3, since it is MWW that are rearranged in 3 different ways. So we have the probability of selecting the first person, man, will be 4/10, and the probability of selecting the second to be woman will be 6/9, because first person is gone. And the probability of selecting the third to be woman again will now be 5/8. So we said we multiply by 3, since the numerators will keep changing from one place to the other, so it's just as good as multiplying by 3. Simplifying this, we have it as 1/2. This is 3, this is 2, 8 gone, 5 and 10 will give us 1/2. So we go to the C part of the problem. The C part of the problem says at most 2 of them are women. Okay, there are a lot of possibilities here. It is either none of them woman, or only 1 woman, or 2 women, and they cannot be 3 women. And if you look at the set, it is only all of them being women that is out of place. We can now use the concept of complement of probability to resolve this. Since the probability of all the possibilities sum up to give us 1, and it is only 1 that is out of this set, so we can just say 1 minus that 1 that is out of the set, which is probability of 3 women. Then we'll now find the probability of 3 women, which is going to give us the first one to be woman will be 6/10, the second one will be 5/9, and the third one will be 4/8. Then we simplify, whatever we get, we take it away from 1, and that will give us the probability that at most 2 of them are women. Most highest 2. We can't get all of them 3. So we simplify, this gives 1/6, so that the probability of at most, that is 0, 1 and 2, will be 1 minus 1/6, and that will give us 5/6. So, and that's the end of solution to problem 4, and this is where we are ending this tutorial. I hope you enjoyed it. Please check the description section of this video on our YouTube channel to get all the videos on probability. Until I come your way again, goodbye.